Good afternoon. So hope you're here to learn how to build some scalable RAG applications. My name is Marcelo Silva. I'm a product manager in Amazon Bedrock. Really honored and privileged for you to give us or entrust 60 minutes of your time to learn about what we have to say and check the new advancements that you saw in Swami's keynote today that we have made to Amazon Bedrock knowledge bases. I'm joined on stage today by two of my colleagues, Mayank Patel from Inverse and Manny Kanuja from AWS. So let's get started. So real quick, the journey is going to be packed. We have demos, we have questions that I'm going to ask you where you're going to raise your hand. It's going to be fully interactive, okay? So I'm going to do an overview of where we are, where we come from in knowledge bases. So a year in review. Then we're going to talk a little bit about some of the features that you heard today and some of the features that were announced on December 1st. Then we talk about some of our experiences dealing with a variety of customers, and eventually what Inverse is going to talk about their journey on building RAG applications with knowledge bases. So we'll talk about somewhat the methodology in which we created those in some of the best practices that we have seen with successful journeys. Then we go into advanced techniques, and Manny will deep dive into some of the announcements of today. We have a very cool demo for you. And then next steps, we'll talk about, we have a challenge for you at the end that we're going to challenge you, and hopefully you're all here to accept this challenge. So let's get started. So very quickly, I know we all know what RAG is, but assuming someone came into the wrong room, was thinking about coming for something else, wants to sit in the back and just, do something else, we're going to talk about what RAG is. So there's many ways of customizing models, right? All the way from customizing the outputs of models with fine-tuning a model, with continued pre-training, as well as one of the most popular ways of customizing a model in contextualizing the output of a model to your data, to your proprietary data that you have in your organization, whether this data is structured or unstructured in a variety of ways, text, visuals, and things of that nature, right? So you have in retrieve augmented generation the capability of adding your own proprietary data or context, if you will, that can be retrieved at runtime, augmented based on the query or whatever way you want to augment that prompt, introducing custom prompts, filtering, and things of that nature, and generate a response or an output from the model. Doesn't have to be generated text. As you saw today, there's plenty of multimodal models out there that could be generating something different. But in this case, most of the use cases today in customer experience or personalized search and things of that nature are done with text, right? So you are creating a data ingestion pipeline to ingest your documents in some way, shape, or form, get a representation of those documents in embeddings, if you will, that eventually you can do searches on and get the specific information to contextualize the output of the model. So you ground what the model is going to tell you, whatever the type of output that is, based on your own data, right? You know all this? Very cool. So last year, exactly a year ago, we launched Amazon Bedrock Knowledge Bases, which is an end-to-end managed service to create RAG workflows, right? So we started to a certain extent very simplistic, and I know many of you in the audience have helped us make the product what it is, right? We have chosen one customer today, which is Inverse, to talk about their journey. But I know there's many folks in the audience and many customers of the thousands and customers that use knowledge bases today and the hundreds of customers that I deal with on a daily basis that have shaped this product. So The important thing to realize is we started small, right? And we are building different techniques, advanced techniques, which you saw today and we're going to go through over the years, over the last 12 months, literally, to have the product be where it is. So what is knowledge bases? Again, we take your data, we find a way to represent this data in a way, shape, or form that's searchable, that can be used as context into whatever the output of the model is, and allow you to ground this data in that context. So instead of having the response of a model, for example, to be based on public information, can be based on your internal documents or structured data or proprietary data in some way, shape, or form, right? The beauty that we have in knowledge bases are the APIs. The APIs allow you to, on a single API, what we call the retrieve API and the retrieve and generate API, to actually use any model in the back end, any vector database that you want, and you don't have to make changes. And as you saw today in some of the announcements, we now have RAG evaluation, which get this pipeline into this methodology finally complete, where you can build your app, evaluate, and reiterate on the app to make it better and better and optimized, right? We'll talk about that when we get to the methodology. So again, I want to thank you because we couldn't do this without you. A year in review, we have developed 50 plus features, which has been amazing. We have the best development and science team in AWS, in my opinion. We have done incredible work to take your requirements, iterate on your requirements, and create features that you can easily get your applications to production faster, or in some way, shape, or form, more accurate and performant. So we introduced things like hybrid search, manual metadata filters, different connectors to Salesforce, Confluence, and others, things like chunking strategies, which is something that a lot of our customers talk about. And we have to remember chunking strategy is not a requirement. You don't chunk these things for the sake of chunking. You have to look at the data and how this data can be best represented to the output that you're trying to provide based on the model that you're going to use. So we introduce hierarchical and semantic chunking, as well as the capability of doing custom chunking versus the fixed chunking that we initially came up with. We also have support for CloudFormation, Terraform, and an SDK and a CDK, as well as some advanced features that we released last year at the this year at the Network Summit, which is an LLM parser or a foundation model parser that allow you to extract entities and customize the extraction of entities of different documents that may contain images, text, or very structured and complex tables, for example. We also have custom prompts that can be now used on our Retrieve and Generate API to further customize the prompts, as well as query reformulation and decomposition, which allows you to decompose the query on complex queries and understand different parts of the query, much like a multi-step search. So today, throughout this week, we made several announcements. I'm not going to go into the details because Manny is going to go in through it. Swami did an amazing job highlighting some of these features. So I'm going to pick a couple of them. One is the structured data retrieval. Last year, we talked about how to add structured data to knowledge bases using agents. And much like the methodology that we try to do and evolve the product, we come with something that allows you to customize your knowledge base. And eventually, we come with a built-in feature to remove that heavy lifting of you having to develop the ingestion of those data sources or optimization techniques or whatever it might be that makes the whole application better and more performant. So we introduced a structured data retrieval. and money is going to go into details of that. We also now, much like you have manual filters in the past, now from a query, we have auto-generated query filters that allow you to auto-generate the filters from a query. We also release the re-rank API, which allows you to do post-processing on retrieval to get the most prioritized content when you retrieve the data. So he has a model, a retrieve model, re-ranker model that allows on post-processing to see all these chunks. What is the most relevant chunks out of the whole bunch that I have retrieved, and prioritize these chunks that can be sent to the large language model or foundation model to get a better answer. We have graph rag. Moni is going to talk about that as well. So now one of your knowledge bases sources can be Neptune as a graph DB, and we can create these linkages and create graphs on the different types of data across many documents and data sources. Streaming responses was launched on December 1st as well. Instead of now having to wait for the whole answer from the foundation model to be generated, it's now time to first token. You start getting the tokens, much like the typing type of thing, as the foundation model generates the answer. So allowing the performance of the models, the applications being much, much better. And as I talked about, we released RAG evaluation and LLM judge, or LLM as a judge, which allows you now to close the circle in creating an app, evaluating the validity of your responses, and then going back and reiterate as you move forward. So this is probably the most important slide on my piece of the presentation. So, and what I want to talk about in here is what we have seen as customers are building scalable apps. And I'm going to talk in general terms. And then Mayank from Emvers is going to come and talk about their journey that allow us to build together this particular methodology. So in RAG applications, you have to have a data strategy. You're going to have different documents types, structured data, and those structured data documents might be manuals, might be financial statements, might be PDFs that are really well formatted, might be a variety of things, CSV files, spreadsheets, what have you. And you're going to have structured data. Having a proper strategy for your data, both from the type of data that you have, chunking strategies, the preparation of this data, the transformation of this data to go into the application, to properly contextualize the response of your foundation model is critical, right? So data preparation is super important. From a RAG infrastructure point of view, the model and vector database selection is also super important for latency reasons, as well as the emerging capabilities of different models. Some models are good for conversation, some models are good for computational type of things, and whatever it might be, you have to know what your users are going to do. Once you decide on the use case and the POC, the most important thing that we have seen is start small and simple. Don't turn every single bell and whistle that we have given you on these 50+ features from day one. Otherwise, you're just going to incur additional cost, create latency, and have no idea what is actually making an impact on your performance, your accuracy, and the recall of your application, right? So start small. Now with RAG evaluation, you can use RAG evaluation to understand the response versus a judge and say, hey, is this response what I'm expecting? Is this within the guidelines of security of my company, the compliance and regulatory requirements of my brand, if you will? And if it is, you can deploy, have users play with it, and I cannot stress enough. One of the most important things that I've seen is people have changed their behaviors talking to these chatbots. They are verbose. They expect these things to be super conversational. They ask things. If you go to one of your business users and say, hey, I put all the files in this thing, you can search anything, get insights, get summarization, they're going to ask all kinds of questions. And you're going to have no idea what they are, right? So it's that process. Go fast, deploy something small, allow the users to get used to the concept of what they are dealing with or the type of services that you're trying to provide, evaluate, make changes if necessary, and redeploy. And it's a continuous improvement process. What I'm going to try to show through what Mayank Patel is going to show with Enverus is it has to be based on a scalable infrastructure, meaning if you start small and you go to something that's complex and you're going to add the different data types, structured data and things like that, you have to be prepared for your infrastructure to not change as the things get more complex, bigger, more documents are ingested, more customers are coming into your platform, and things like that. So without further ado, I'd like to introduce Mayank Patel from Enverus to talk about his journey on building RAG applications with knowledge bases.
Thank you, Marcelo. Thank you. Hey, how are everybody doing today? All right, let me introduce myself, first of all. My name is Mayank Patel. I'm Distinguished Architect at Enverus. Enverus is a leading SaaS provider providing a solution for the entire energy spectrum. We cover supply chain, back office, power and renewable, trading, all type of solutions. I'm genuinely excited today to talk about the journey we took through the AWS partnership with Marcelo and Manny and how we approach building Instant Analyst, a scalable RAG platform. So yeah, let's kind of start here first. The challenges everybody facing today is the gap between your raw data and the value you want to create, right? Same thing, energy industry have mountains of data and the value is buried within that. So how do we unlock this? This is kind of where it creates the information disconnect, and how Enverus solve the problem is through the intelligent connection. Now, solving this problem, what we provide to our customer is unlocking a new value, new potential of what they can kind of do with the energy prediction and future and shaping the their journey, providing the value to the industry. Now, when we close this gap, kind of really it helps everybody, not just the energy company, but it helps the end user who's consuming the energy. So that's our mission. At the heart of everything we are doing is a powerful mission that drives the technology innovation, right? We are democratizing the energy across the entire ecosystem, as I mentioned, major producer to a small supplier. Also, we have the financial organization and global trader, local operators, everybody consumes the solution Enverus offers. When quality data drive decisions, energy becomes more affordable, reliable, and cleaner for everyone. And that's what drives our innovation at Enverus, powering the global quality of life. Now, let me show you the scale and impact we are already achieving through the building the Instant Analyst as a scalable and flexible RAG solution. The Enverus advantage. Number tells an incredible story, the scale and transformation in the intelligence, energy intelligence. Let me show you why. 98% of the energy producers and 35,000 plus suppliers are on the Enverus platform. They trust us, processing over 200 billion plus spend through just one of the Enverus product out of the entire product suite Enverus offers. With 5,000 plus energy customer, 300 plus financial institution, they use the Enverus every single day. Let's focus on Instant Analyst. Our expert analyst delivers SEC verified information that worth 25 years of data that combines structured and unstructured data. Now, let's talk about the scenario. As you all might have faced a situation, you are trying to research something and going through a vast amount of data to aggregate, find the information you are looking for, synthesize, and finally able to make a decision. That's the same problem our customer have. We provide a lot of industry research report. However, each report can take 10 to 15 minutes to read. Now, think about it. The producer in the Louisiana somewhere trying to drill new well, and they do wanted to basically understand what are the regulation changes and everything. They have to go through each of these report and follow up and come up with a decision. That takes very long time. It takes days to weeks and sometimes kind of even longer. With the instant analyst, we are able to offer and decrease this kind of time for the user, increasing the efficiency gain for many, many customers. How? Instant analyst supports the full 25 years of data through the RAG platform, and now our user can query, get the answers with the factual accuracy. Through the citation, they can go and validate the data. With this solution we built, we were able to onboard 52,000 plus users in less than 1 quarter on the instant analyst. Okay, so let's jump into Enverus' journey. Marcelo talked about the methodology. So how methodical journey we approach for the instant analyst, let's talk about that. Building a scalable and flexible solution. We structured these into 5 key phases. First, planning and strategy. Have your business a vision and then build upon a strategy on it. Validate your idea very early. Do not go through a lengthy process to build a solution, kind of waiting for the industry and everybody how to approach this, but validate the idea however you like, and then make sure you have the right team and a culture established. This goes from the top all the way from a business to your engineering team, and everyone needs to be supporting and adopting the change. Generative AI is a different fundamental how we build the application. Development and integration. We always focus on infrastructure as a code. I think many of you over here build the demo application for your organization, and you know how that goes. It becomes the production solution. So start with the infrastructure as automation. So you can kind of like, again, once the demo is there, once product says, let's scale it, you can support that. Engineering in focus. When generative AI kind of comes in the discussion, I think everyone thinks of the algorithm, and then the scientific research is what we need, right, in the team. However, there is a lot more component which requires the orchestration, engineering, architecture, right? So I think that's what the focus needs to be, building a scalable RAG application. There are many components such as memory, vector stores, and all these pieces to put together. It's the orchestration art. AWS integration. That's the most critical, is during your development process, include and partner with your account team from the AWS and validate your design and implementation, bring the challenges to them. That way you can get the Bedrock or whatever different team you need kind of support from. They can come forward and then kind of guide you with the different type of solution or services available or design pattern. Testing and validation. This is the most critical piece into building a generative AI application. I think everybody over here who are trying generative AI of some sort, I think you might agree with this, that tasting the response or content generated by AI is very, very hard to taste, right? So the approach we took is a 3 different way. First, we focused on a market testing without trying to get everything done. Find the best customers you have and bring that to a market testing phase. We were able to, lucky enough, we had hundreds of customers in less than 2 months able to sign up into our Enverus Instant Analyst platform and give us very, very good feedback through the call, through our system directly, and then through the account reps. A/B testing and evaluation is the another main kind of focus we put into our testing. infrastructure as a code we used to deploy multiple knowledge bases in a parallel with a different vector store, different configuration, different embedding model, same data. And using the A/B testing, now we are able to kind of give into the user's hand so they can compare and give us the which solution or which response they like. So we get basically through the market feedback and A/B testing validation of which configuration is working better, as well as the evaluation. So evaluation is we started with the open source Ragas framework. I think many of you might be using over here. Ragas gives really good for the RAG matrices. However, we were able to implement a complete end-to-end solution. However, that brings a lot of development overhead. Let me tell you why. As kind of a recent announcement of Ragas 2.0, that's a complete revamp. It means your development team had to spend more time redoing or re-implementing your evaluation framework. I think this is one of the reasons I'm really excited about the kind of feature Marcelo highlighted earlier of model evaluation as well as RAG evaluation, LLM as a judge. So I'm very excited, and we are looking forward to try that feature out for our system. Platform and security. I think when AI comes in, another hot topic is the security. The reason we really, really like the Bedrock, it gives you protects your data within your virtual private network. It does not leave, right? So I think that's kind of like a common sense basically to use the Bedrock for that region versus calling a third-party APIs and hosting the model somewhere and like worry about your security team kind of reaching you at the night. Optimization, so from the testing and validation, whatever the feedback we gather, also optimize iteratively on that. And then platform build. Everything we build at Enverus, our focus is a platform in mind. We do not want it to start the process for each use case separately. We wanted to design a system that can scale easily for more than one use cases. That's how we approach the instant analyst as well. We designed the configuration as a code model. So first RAG use case we built for the instant analyst for a research, intelligence research data. We design in a way that like following after that, in hours and days, we are able to bring a new use case onto our platform without spending 6 to 8 month or 12-month long effort. And finally, once you feel comfortable, the product is kind of like getting a good feedback and good accuracy, prepare for the GA launch. That's not a done deal. This goes back into a continuous improvement. As your product, stakeholder, business, customer, everybody gonna bring new, more complex requirements. As we gone through and seen these over and over again, different type, intent of questions to handle, different types of data, how you bring it into your platform, this just continuous, like a new innovation needed on your platform. And our system, the way we designed every step of the way, our focus was the scalability and flexibility, which you can see the validating idea, infrastructure as a code, evaluation, all of the things we did in an automated way, and then that keeps kind of like giving us the value, like how fast we can bring the new use cases or features to instant analysis. So let's talk about the challenges. Again, as we begin to orchestrate this scalable architecture, we faced critical technical challenges like many others over here kind of might have seen it, right? Please raise your hand if you have. Yeah. First, getting chunking suited for your use case and your data and type of responses you are trying to get. Then keeping the data synchronized from your primary source system into a vector store. By doing this through the API calls, kind of like your homegrown implementation, it becomes very tedious and kind of you have to maintain this. Also, like when you direct integration to a various kind of like a platform without Bedrock for the LLM or embedding model, you have to make sure that you have the throttling and back pressure handling implemented in your solution. Otherwise, you will get a lot of rate limiting error or failures when the API is unavailable. So these features are kind of again brings in a lot more development effort from your development team. Continuous improvement, and the most importantly, the retrieval accuracy. There is a never 100% accuracy into a RAG solution or any generative AI application. This is like everybody needs more, right? I need more. That's the kind of from product and user when you talk to what comes up. So after talking to a AWS team, we had found the solution is Amazon Bedrock knowledge bases. What Amazon Bedrock knowledge bases offered us is ability, like I mentioned earlier, is Terraform infrastructure as a code and A/B testing. So we were able to deploy multiple knowledge bases in a parallel for the same data with a different configuration of chunking or different embedding model. And now we are able to make a data-driven statistical decisions. So the chunking problem over here, rather than spending kind of each singular iteration, we are making a data-driven decision in a parallel, much faster. Also, the Bedrock knowledge base kind of supports, handles the synchronizing, keeping the data into a sync. So if you kind of have the updates or delete or any different type of operation on your data, that can natively handle it. You do not have to worry about this. Throttling and all that is kind of like natively baked into the Bedrock knowledge base. And then the last but not least, for the retrieval accuracy, it gives a hybrid search, metadata filtering, now re-ranking, all of these techniques kind of from our integration and partnership, what we kept raising a different feature request or needs for our system, it keep coming from the Amazon Bedrock team, and we are really happy about that. So that helps with the improving the accuracy. Now let's dive deep into kind of like our high-level architecture of the instant analyst. So what we kind of like did over here is this is a 100% serverless architecture, event-driven. We do not want it. We don't like the manual operations or polling type of mechanism. So it's an event-driven architecture. What this offers us is our analyst who publishes the research report, in matter of less than 5 minutes of publishing the report on our platform, it goes through this pipeline, data ingestion pipeline, through all the various different techniques, and the data is prepared to bring it in the vector store. This is data ingestion into a RAG, also very, very critical piece. Again, garbage in, garbage out. So you have to get your data very enriched into a vector store so you can query in a variety of different ways and get the information you're looking. So a few things I wanted to highlight over here. There are 3 main kind of like focus area into this one. The way we approach is the retrieving the information from various different formats, structured, unstructured data. We support the formats like PDF, JSON, Excel, CSV, as well as the audio and video formats. So the retrieving and standardizing into a standard format. Then the middle section there focuses on the cleanup. So we have automated cleanup of the data as well as human in the loop, where we build out the solution is as your data flows through, it can go through the pipeline, through the automated into a vector store, synchronizing that data. And then later on, then human in the loop can come in, pick up the data that needs to be enriched, and then kind of like just updates that automatically. And then the final piece is vectorizing the data into your index, whatever the vector store you are using. Let's dive deeper. So you kind of like heard me telling that like this is a 100% serverless architecture. So you can see we'll leverage the serverless kind of stack of the step function, Lambda, Event Bridge, SQS, SNS, all of this. But there are 2 things you see into the data ingestion pipeline over here is the Amazon Tech Stack and Amazon Bedrock. So we have a PDF data which has a table embedded within the PDF. There are charts and variety of different structure, partial structure as well within the PDF. So how we approach this into a second section over here, transforming the data format, you can see the tech stack. We OCR this report, which using the Amazon Tech Stack gives us a JSON, and then from there we are able to transform it into a standard format. Later on, it goes through the automated manual human in the loop process, and then we leverage Amazon Bedrock to enhance the context of this data before it goes into a vector store. We started with originally Amazon Kendra, and then later on we were kind of like, as we mature and we wanted more control on our vector store with a different algorithm, we were able to switch to the OpenSearch by leveraging Bedrock knowledge base. OpenSearch, so on the retrieving side, the RAG augmentation and generation side of the architecture, we also, when we jumped into OpenSearch and leveraged the OpenSearch LangChain retrieve API, that gave us the semantic search capability. However, as I mentioned, the need always higher. We want more, right? So the metadata filtering, there are so much metadata around the data, and customer and our business would like to support that, querying that through the instant analysis. OpenSearch and LangChain directly does not support the hybrid search, and that's where we kind of like switch over to leveraging the Amazon Bedrock knowledge bases using the retrieve API. Retrieve API also give us something like a very good abstraction layer for the any vector store. So now we can kind of create more vector store with a different configuration, and we continue using the same retrieve API. So we do not have to make any code changes when we go from one to a different vector store. Retrieve API handles taking care of that. Not just the abstraction, but it also brings many other kind of advantages, such as the built-in semantic and hybrid search capability, implicit and explicit filters. Now, let's dive into we enhance our accuracy through the key stages, 3 key stages: pre-retrieval, retrieval, and post-retrieval. This is very important. Like, so the pre-retrieval, we focused on the query enhancement and getting the information from the query. So we called it query parsing mechanism. We implemented all of these. We originally implemented into a homegrown solution. Later, we partnered with the Amazon, and how we always wanted to bring this feature into Amazon Bedrock knowledge base, so everyone kind of, all of you can also use it. That's how we contribute back with the feature request and the solution to the AWS team as well. So query parsing, rewriting, and then the expanding, and any other terms you might have heard of, the reformulation. This is very important because the query parsing, the approach we took is you can ask a question is a specific in a time and all that. We can extract the specific pieces of the metadata information from the user query, and we can apply the implicitly later on when we are doing the retrieval. So that is very helps with the accuracy. Now the retrieval is hybrid search and dynamic filtering is what I mentioned as well. Dynamic filtering supports the implicit and explicit filters both combination. And then assembling technique is just combines all of the data from your different mechanism. Post-retrieval is now, let's say, kind of like based on context, we had a 25 years of data, but like getting an answer for a specific question is very hard because there is a specific terms or semantic used across these thousands or millions of documents. So getting the right chunk is still very hard. So re-ranking is very important. It kind of re-ranks the chunks. You can pull 500 or 1,000 chunks, and then you can re-rank that to relevant to your context. And then time recency and relevance. Somebody is asking a question that needs to be a specific in a time a report is published back at 3 years back, or somebody needs the recency is like last couple of weeks or a month, like on a specific topic. Right? So without losing the history, it's very important to get the relevance and recency handled through the system. Last but not least, the streaming. So once you have all of this and responses generated, make the experience seamless for your user using the streaming. So as soon as the LLM model starts generating a first token of your response, you can start kind of giving that information to the user, and you will see that into a demo. Key takeaways is AWS advantage, fully integrated Amazon Bedrock. This gave us, as I mentioned earlier, is security and high performance. We really, really like using the Bedrock versus kind of like hosting or going through somebody serving the APIs for the LLM. Our user confirmed that they are spending less time into researching, and they are spending more time in making decisions and spending the time where really they need. All these information is pulled from the trusted sources off of all of our research published by our analysts, SEC verified research reports, 25 years of data. And Enverus and AWS partnership, I highly recommend each of you over here, if you're starting building a scalable RAG solution, talk to your account team, bring in someone from the Bedrock team to work with you. How we approach at the Enverus is we started with a bi-weekly integration. We brought our design and implementation idea and the demo to AWS. We validated we are on the right path, or do we need to change something. And from that, we were able to bring a lot of challenges and a feature request to Amazon team with the solution we presented to bring that into a Bedrock knowledge-based platform so everyone can use it. Let me show you Instant Analyst in action. So if you're an Enverus customer, you can use it today. We have an Enverus Analyst mobile application as well as the Enverus platform, kind of through the web, you can access it. This gives a very seamless experience, and you can see like how fast. It's a very low latency system. It makes the user kind of feel like getting the information. That gave us, the user gets the something to get started. This is a fundamental shift into how you ask the question or get the information. So we provide an example question to give an idea what type of question or what you can ask. From there is a citation available. So our motto is trust it, but always validate. So user can always go to a specific report and a page number and a section, and they can validate where that information comes from. Without further ado, now I'm really thrilled to bring Manny Kanuja on the stage to walk us and deep dive into all the new features and where Amazon have presented in the last couple of days and throughout the year. I wanted to give a kudos to Manny into like bringing many of the features and then the challenges we have at Enverus to life. So thank you, Manny.
Thank you, Mayank. So it's afternoon, and I know that we are more than 50% of our session with last 20 minutes left. And I just want to make sure that we are still with energy, right? Not sleeping. So if you are, I won't complain. I just want you to be just awake for my part. Okay, with that. So Mayank shared a lot of things with us. And we are so fortunate to have customers like Enverus who are helping us shape our product. So thank you so much for being here with us. And also, I want to introduce myself, which I forgot. So I'm Manny Kanuja. I'm Technical Lead Generative AI Specialist at AWS. Very excited to be here, and I'll be talking about a lot of advanced techniques for building scalable RAG applications. Mayank and Marcelo have already shared a lot with us, so stay tuned for some more of it. So they have talked about how you can start small by building your proof of concept and then taking it into production. What are the best practices? So I'm not going to repeat that. However, what I'm going to talk about is how we can have multimodal data processing into our RAG application. So this is an important piece. The reason is our documents are not just based on text. We all know that. They have images, they have tables, and there is a lot of information in those documents that we want to leverage into our RAG application. And that's the reason why multimodal data processing is important. And the good news is that we have it as part of Amazon Bedrock knowledge bases. It's a fully managed solution. All you have to do is bring your data and select either Amazon Bedrock data automation or foundation model as a parser while you are creating the knowledge base. And once you are done with that, do not forget to sync because nothing will work. So make sure that you have synced your documents, meaning that you have ingested the documents into the vector store. And once it's there, just ask questions. And if your questions or if your answers are getting retrieved from the images, you will get images in your citations. Isn't that cool? Without doing anything, everything taken care by AWS on your behalf. So that's the reason why I really, really like this particular feature among all the things that we have launched. So this is about the multimodality of the data and how we are processing this multimodal data. But what if you have questions which cannot just be solved by unstructured data or introducing the multimodality within this? What if you have questions like, what was the top selling product in November 2024? What will that entail? And why am I pointing out to this simple question, you would wonder? Because it might require to look up into your databases or the data warehouses, right? It might require to do aggregation. So the expected answer would be something like this, that my top selling product is car seat covers. I'm not saying that that should be your product. That's just an example, right? So something like that you would expect that based on your database lookup, it should fetch the right product, it should fetch the number of quantity that has been sold, something like that. But remember, we are still talking about RAG application, which means we are talking about conversation. So we want to make sure that it can continue with the conversation, and you might ask another question, what is the current inventory of it, by not mentioning the name of your product. And again, your expected answer would be, that it should have the same product that it was talking to before, right? But again, all of this, we are not talking about unstructured documents. This requires database lookup. This requires aggregation. This requires understanding your data, schema. This requires understanding the relationship between the tables. It requires a lot. So to answer questions like these, what would you need? You would need to translate your natural language queries and generate the SQL query out of it, right? So how would you do that? You cannot do that if your model or your system cannot understand the data. If it cannot understand the schema behind it or the query engine. So there are a lot of challenges and a lot of intricacies while building this, right? And accessing the structured data is no longer similarity search. It's more than that. We all know this. So what do we have? I only have good news today. And the good news is that Amazon Bedrock knowledge bases now provides you with native support for structured data retrieval. So what does that mean? What do you have to do to leverage this particular feature? What you have to do is, as you query your data, once you have built out your knowledge base using this structured data, connecting your databases, what you will do is, you are going to ask question in a natural language, very simple to what we have on this screen. What was the top selling product in November? I'm going to stick with the top selling product, so you don't have to think about multiple queries, right? So you'll ask the question in a natural language to the knowledge bases, and the knowledge bases, what it is going to do is, it will first generate the SQL query, right? Because that is important. And then you have to run that SQL query against your database. So it will do that on your behalf. And how will it do that? Marcelo talked about the two APIs, the retrieve API. So we are just using the same retrieve API, which will run this generated SQL query to give you the results back. And if you are saying that, you know what, but I just want to generate the SQL. I don't want to run it just yet. Then we are also providing you with additional API called the generate query API, using which you will be able to access just the query that was generated. That's number one, right? And then if you use the retrieve API, it's going to give you back the results. But we want more, right? This is not RAG application just yet. There is one more piece to it, summarizing these results to get the answer back in a natural language, right? And also, providing source attribution and citation is an important piece. And what do we need with the source attribution and citation in this example? Obviously, the generated SQL query, right? So you will get that when you use retrieve and generate API. So what the user experience will look like, let's take a quick demo and see it for yourself. So the first part is that you are going to select the model. In this case, I'm selecting Claude 3 Haiku model. You can select other models that are provided, that are supported. Once you have done that, you're going to ask your favorite question. What is the top selling product in November 2024, right? So when you are asking question, what it will do, it's going to do three things for you. Number one, it will generate the SQL query. Number two, it will run the SQL query against your database, right? Three, it is then going to summarize the results that it get back to give you the answer in a natural language, right? Something like this. And then you can ask a follow-up question. For example, again, what is the current inventory level for it? And then it will give you the results back because we are maintaining the conversation history, no need for maintaining session IDs or anything. It's been taken care of. So that's why we say that we are taking away all the heavy lifting from you, right? And now I want to have a quick show of hands. Whosoever liked this particular feature? Okay, awesome. So if you like this feature, you will continue to look what I have to say again. So now you would say that if I just want to see the data sources as I talked about earlier, so then you select that, retrieve data sources only. You ask the question in this particular case, then you will see the responses back. It will not give you the full response, it will just give you the retrieval. It's going to generate the query, it is going to run it, and it will give you the results back. And if you just want to see the generated query, then you have to change the option again. In the retrieve and response generation section, you will say generate SQL query. And then you can just see the generated query. Isn't that cool? Right. So, and also I saw a lot of show of hands who were interested in this feature, right? So my next thing is we do have another session which goes very deep into just structured data retrieval. It's a full 1 hour session on that. And I would request each one of you who are really interested and who raise their hands to go and to this session as well, which is on Friday, December 6th, 10:30 to 11:30 a.m., same Venetian level 3. So absolutely, if you're interested, we have a lot to talk about this feature. Okay, so enough about structured data retrieval. We talked about unstructured, we talked about multi-modalities, we talked about best practices. Oh my God, we covered a lot. But this is not the end, this is just the beginning. So what if you have questions that requires to understand the relationship between the different documents, right? I know you would have already figured out where I'm heading towards, right? But what if you have a query, something like, what is the capital city of the country where Eiffel Tower is located? Sounds simple, right? We all know the response. But if you're asking a RAG system about it, then how is the RAG system going to respond? Is the basic RAG system that we talked about is going to work over here? So let's see that. So let's divide this question into two parts. The one part is, what is the capital city of the country where Eiffel Tower is located? So first, I need to fetch the location of the Eiffel Tower. So if we are talking about a basic RAG system, it can definitely give you the documents where we have Eiffel Tower. It can talk about the capital of France. But will it be able to connect those two pieces of information together if they span across many, many documents? Right? It may or may not. So how do we make sure that we are handling such type of queries effectively? We make sure by using GraphRag. So Amazon Bedrock knowledge bases have GraphRag in preview today. So again, you keep hearing this word, we take away heavy lifting, it's fully managed, and it really is. The reason is, whenever we are talking about GraphRag, we are talking about understanding these relationships between the entities across many, many documents. What does that mean? That means that your graph RAG system is as good as the knowledge graph that you are creating. And how do you create a knowledge graph can be tricky when you have lots and lots of documents. So what we are doing when we say that it's a fully managed, we are building the knowledge graph on your behalf. We are taking care of all the entities and the relationships that you might have within your documents, right? So all you have to do is you will connect your vector store, select Neptune as your vector store so that when it can generate the graph and store the graph, and then start asking the questions once it's created using the same retrieve as well as retrieve and generate APIs, same APIs that you are used to using it, right? And then this will help you in building more comprehensive RAG applications. And that's what we meant with scale, right? We have to scale. We have to make sure that the systems are working together across thousands and thousands of documents, and even more than that. So this was about the graph RAG. So I would just like to recap on some of the stuff that we talked about. We talked about the methodology of building scalable RAG applications, how evaluating your applications, continuous improvement that Marcelo shared, and then followed by what Enverus provided us with their amazing journey on how they started small, the best practices to move into production. But also in the beginning, we talked about a challenge, right? So we do have a challenge for you. And the challenge is to get started, to start your journey if you haven't yet already. And if you've already started your journey, talk to us, reach out to your account team, build a RAG application. Give us new challenges, provide us feedback. Let's partner together on this journey of building different RAG applications, right? And who knows, while we are doing that and you are helping us shape our product with amazing new features and amazing new problems that we solve together, that next year, maybe one of you would be on stage with us talking about your journey and sharing it with everyone. So with that, thank you very much for your time. And these are the QR codes.